Power in AC circuit.
Alright, so today we are looking at power in AC circuit. Power in AC circuit. Basically, there are three power we are considering today. In AC circuit, there are three different kinds of power. You have the apparent power, you have the active power, and you have the reactive power. So now, what is an apparent power? The apparent power is measured in volt ampere, and honestly speaking, speaking of it, it's the total power that flows. Yeah, so it measures the total current, that is the total power that flows within a particular circuit. That is to say, the apparent power is simply the magnitude of the summation of the magnitude of the reactive power and the active power. So now the active power is more or less like the real power, the true power. That is the power of that we normally calculate, which is measured in watt. So the power is equal to IV, which is measured in watt. So the power that is transferred within a specific time. That is so the I VT, that is the energy transfer times the time. And this power is known as the active power. So when you transfer, when there's a work done, there's an energy produced. So the amount of energy produced per times the time consumed becomes the power released or the power absorbed. I get it. So that becomes the active power. And that one is measured in what? So the apparent power is measured in volt ampere. And now we have the reactive power. And the reactive power is more or less like an imaginary, it's not real, so an imaginary power. And most of the times, the reactive power you get it from inductive motors or capacitive cells and others. So now we get the reactive power from these kind of things, and it's measured in the unit of volt ampere reactive. It is measured in the unit of volt ampere reactive. Okay, so now when you join all these three powers together, you have something we call the power triangle. I think when I use the power triangle, you understand what I want to explain. You have something we call the power triangle. Okay, so now with the power triangle, it is a right angle triangle. Okay, so when you are considering the image that is on the board, the image that is on this side that is on this side, realize that this side, the hypotenuse, is the apparent power. The hypotenuse is the apparent power. I have an angle theta here, and my opposite side here is my reactive power. So my apparent power is represented or denoted by the symbol S. So now the S is equal to IV. The reactive power is denoted by the symbol Q, which is equal to IV sine theta. Okay, so now if you want to find the theta here with this, that is sine of opposite, that is Q divided by the hypotenuse. That is what we are getting IV sine theta. So sine of the theta here. So the reactive power is here is what? Is Q. But how do you get a Q? It is what? Opposite over what? Hypotenuse. And opposite is what? Is the Q. And the hypotenuse is what? Is the Q. And the hypotenuse is the S. And the S is what? IV. So therefore to find the Q is what? IV sine theta. So that's what we are getting it. And down here is the active power or the real power. So the adjacent is the active power is denoted by P, and that one is IV cos phi or cos theta. Okay, that is the angle. So now realize that here, what we can denote from this particular aspect is that the S is equal to IV. So we have the reactive power, which is IV sine theta. And we have the normal power, which is what? IV cos theta. So if you check the power triangle here, So from Pythagoras, we can see that x is equal to the square root of p squared plus what? Q squared. S is the square root of p squared plus what? Q squared. But take note that the S is measured in volt ampere, the P is measured in watt, and the Q is measured in volt ampere reactive. Volt ampere reactive. Okay, these are the three powers we can find in an AC circuit. So what happens is that now the cos theta, the value for the cos theta we have here is what we call the power factor. The value for the cos theta we have here is what we call what? The power factor. Now, when you come to the power factor can be lagging or the power factor cannot be lagging. So the power factor here is simply equal to P on S. Why P on S? If we find the cos theta on this cos theta here, so cos theta is equal to, that is adjacent. So adjacent is P. The adjacent here is P divided by the hypotenuse, which is F. So now ensure that P of F is the same as what? The cos theta. And that's what? The power factor. Now the power factor you have here may be lagging or might not be lagging. Now, when is the power factor lagging? So the power factor is lagging when current in the circuit, current lags voltage. So the power factor is lagging when current is lagging voltage. But the power factor is leading. So the power factor leads when current leads voltage. The power factor leads when current leads voltage. So these are the things I want you to actually take note of very well. But let's look at something here, which is also very interesting. Something very interesting here. Okay, so considering this as your graph, we know that in inductance, we have our resistors which are in phase, and we have our impedance, that is the Z, and we got our let me put it here for you. You got our inductor and our capacitor. Okay. So now this helps. So let me just use their reactances. So capacitive reactance and the inductive reactance. Okay. And this was our angle, for the phase angle. Now what we can say about these two things is that one, you realize that we can redraw this diagram in this nature. That will also help you understand. So if I'm drawing this in this nature, I'll have my Q here, I have my P here, and I have my S here. That is the apparent resistor. So now what happens is that resistors, that is here, resistors only consumes P. So resistance only can consume the active power. So if you compare this diagram and this diagram, this is the power triangle. So when I bring the Q here, it makes the same angle. So resistance only consumes P. That is the same direction. Now when we come to inductors, inductors consume Q. Inductors only consume Q. That is the reactive power. So inductors only consume the reactive. That's why when I'm talking about the reactive power, I said it's an imaginary or non-real power most of the time produced by the inductive motors. So most of the time produced by the inductive motors and sometimes by the capacitive. Yeah, but not all times. And also the capacitors. The capacitors, they do not consume any of them. They do not consume any of them. So you like that there's nothing here. But the capacitors, what it does is that because it's the same, like if you take it like as wires, the capacitors will rather supply or they will tend to reduce the reactive power. That is why I said most of the time it's not all some of the capacity products, capacity machines, they will rather supply or they reduce the reactive power. So this, I think this will really help you build the stuff. So the next video, you enter into questions where we can find these powers in an electric circuit or within an electric a circuit problem. How we can find the apparent power, the reactive power, and the active power. Bye.